This video, we're going to be looking at the rational zero theorem. So the rational zero theorem gives a method to determine all possible zeros for a polynomial. And so if we have a function fx equal a sub n, x to the n, n is the degree of the function, so n would be the largest value, right? So we have a sub n, x sub n, plus a sub n, n minus 1, x to the n minus 1 power, and so on, all the way down to a sub 0, which would be our constant term. Okay, so here's our constant term. Here would be our constant term. And the n will be the degree, right? The degree of the function. So all possible zeros would be plus or minus the factors of a sub 0 over the factors of a sub n in lowest terms. And when we reduce to the lowest terms, we see that some of the possible zeros repeat themselves. If you're looking at like in a textbook, you'll see P over Q, okay? So if you're looking at this elsewhere, you want to follow up, they'll have it as P over Q, but the P is referring to factors of a sub 0, and the Q would be referred to factors of a sub n. Okay, so let's look at an example. So list all possible zeros of fx if we have 2x squared plus 13x plus 2, 0. So the possible zeros, so the factors, so our a sub 0 is equal to 20, and all the possible factors would be 1, 2, 4, 5, 10, and 20. And then if we look at a sub n, which would just be 2, right? The coefficient in front of the largest power. These factors here would just be 1 and 2. So possible zeros would be, so let's start here. So we have 1 over 1, which we know is 1, 1 over 2, right? And then let's start with 2. We have 2 over 1, right, which is 2. And all of these are plus or minus, by the way, all right? So even though I'm not putting the plus or minus, it is plus or minus. So the next one is 2 over 2, but we already have 2 over 2, all right? We already have 2 over 2. And we continue, right? Next one is 4 over 1, 4 over 2, but that gives us back 2, which we already have. 5 over 1, 5 over 2, 10 over 1, 10 over 2, which is 5, which we already have. And then we have 20 over 1, and we have 20 over 1, and then also 20 over 2, all right? But some of these we already have, so we can knock some of these out. Okay, so like 2 over 20 is 10. We can knock that out. So our list Let's go with our list, and then we can knock on. So we have 1, we have a half, we have 2. Well, 2 over 2 we already have. 4 over 2, that's 2, so we already have that. 5 over 2, we have 10. Well, 10 over 2 is 5, which we already have, and then 20. So these are all the possible zeros. So I don't have to waste time searching for possibilities. We know that one of these factors, plus or minus on all of them, will divide into this function up here. All right, so let's look and see what happens. So our next question says find all rational zeros. So I'm going to use synthetic division here. And so using synthetic division, I like to start with the lowest one. So I'm going to start with that 1. So I'm going to start with plus or minus 1. So let's start with plus 1, right? So we have 2, 13, 20. And so we have 2, we have 15, we have 15, this is 35. So this doesn't work. Let's do minus 1. We have 2, 13, 20. So we have 2 minus 2. So this would be 11, and then this is minus 11. So this also does not work. So neither 1 or minus 1 works. Let's try a half. Let's see if a half works. So we have 2, this is 1, we have 13, 1 and 13 is 14, and here we have 20. So a half does not work. Let's try negative a half. So we have 2, 13, 20. So this would be 2, this would be negative 1, this would be 12. This would be negative 6, which is 14. So far, nothing seems to be working. Well, if we observe the positives, since everything up here is positive, right? The positives just seem to be making it bigger. So let's just do the negatives. So we've done 1.5. Let's try 2. So let's try the negatives and see what happens. So we have 2, we have 13, we have 20. So we have 2. That'd be negative 4. This would be 9. And this would be negative 18. Okay, so this one was kind of close. All right. So the next one we could try is a negative 4. So we have 2, 13, 20. So this is 2 minus 8. That would be 7. No, not 7. Sorry. This would be 5. So we have minus 8. This would be 5, so negative 20. Okay, so this one works, all right? So this would mean that we have a factor, because the minus 4 is the additive inverse, so we have a factor. So one of our factors is x plus 4, right? X plus 4. And then this remainder is 0. right? This is why minus 4 is a 0, because the remainder is 0. The remainder here, this is our remainder. Our remainder is 0. And then this is our quotient. Well, if we look at our quotient, it's 1 power less, right? So we started with x squared. So 1 power less would be, make this 2x plus 5. So here's our second factor, right? So we have x plus 4 and 2x plus 5. So, right? So it said find all rational zeros and factor fx. Okay, so that means fx, that means fx, which is equal to 2x squared plus 13x, factors out to equal x plus 4 times 2x plus 5. All right, let's look at another example. Okay, and the zeros here, we'd had to solve for, like over here, we'd have to set 2x plus 5 equal to 0. So we'd have gotten x equal to minus 5 over 2, right? And if we had solved for x over here, we'd have gotten x equal to minus 4. So the zeros for fx are minus 4 and minus 5 over 2. All right. And if we go back and look at our possibilities, here is the 4, and remember it's plus or minus, and here's the 5 over 2. All right. So they are on our list, right? The zeros are on our list. Okay, let's look at one more example. Okay. So here we want to list all possible zeros again. We know the constant, our constant term is a sub 0, and the 6 is our a sub n. All right. So we know the possible zeros are factors of 2. Okay, so factors of 2, 1, 2. Factors of 6 would be 1, 2, 3, and 6, right? Okay, so let's go through it. Let's use 1 first. So we have 1 over 1, 1 over 2. Next up, it's 2 over 1. Well, 2 over 2 is 1, so we're going to ignore that because we'll have to come back and strike it out anyway. So we can ignore that. So, all right, I think, okay, so I did 1 over 1, 1 over 2, but I did not do 1 over 3 and 1 over 6. So let me make sure I add that in. All right, so now I'm doing 2, so 2 over 1, that's 2. 2 over 2 is 1, which we already have. Okay, maybe we should write it in just to make sure. 2 over 2, 2 over 3, 2 over 6. Okay, and that seems to be it, right? That's all the possibilities. Okay, so now this simplifies to become 1. This simplifies to become 1/3, right? Okay, so let's go through our list. So we have 1, we have 1/3, we have a half, we have 1/6, and then we have 2, and we have 2/3, right? So I think that covers all the possibilities, right? So All right, so, and all of these are plus or minus, all right? All these are plus or minus. Okay, so find all rational zeros and factor into linear factors, all right? So we could start, let's start with 1. So here, we're using synthetic division again. So we want all the coefficients. So we have 6, 7, minus 12, minus 3, and 2, right? Okay, so we have all the powers starting from 4, going all the way down. So here, if we did 1, we'll have, bring down the 6. 1 times 6 is 6. 6 and 7 is 13. Then we have 13 here. Then we're left with 1. 1 times 1 is 1. Then we're left with minus 2. And then 1 times minus 2 is minus 2. So we have a 0 remainder. So the factor x minus 1, right? X minus 1 is a factor. Okay. The plus 1, this plus 1 is the additive inverse. Okay, so we started with x to the 4th. So this quotient that remains here would be 6x to the 3rd plus 13x squared plus x minus 2. All right, so we got one factor out of that. So we've already used up, we had already used 1. So let's try and use minus 1. But we are going to apply that minus 1 to the quotient, all right? And if you look here, we have 2 as a sub 0, and a sub n is equal to 6, which were the same things as the previous function. So the possible list also applies to this anyway. Okay, so let's use negative 1 as a possible 0. So now we have 6, 13, 1, minus 2. So here we have 6. We have minus 6. This gives 7. So it's minus 7. And this would give me 6. So minus 6, so negative 8. So this is not a 0. Okay, did I write this down correctly? Okay, yeah, here's where I made a mistake. So here, this is, let me do it in red just to highlight. Yeah, so I made a mistake here. This is minus 6. And so this would be plus 6. Okay. Okay, so here, this would be 4. Okay. All right. Okay, so let's try. I'm going to try the next whole number. So I'm going to try that 2 and see if it works. Okay, so we're trying 2. We have 6, 13, 1, minus 2. So here it is 6. This would be 12. This would be 25. This would be 50, 51, 102. So this is way out. Let's try negative 2. Okay, so that's 6 minus 12. This is 1. This is minus 2. So this would be minus 1, and then this would be plus 2. So here we go. So this is a 0. So this means what? This means that x plus 2 is a factor of fx, all right? So we have two factors so far. We have x minus 1 and we have x plus 2. Well, this is 1 power less. So previously we had 6x to the third. So now we'll have 6x squared plus x minus 1. Okay. So here we could just do regular factoring, or we could use the quadratic formula. So here I'm going to do factoring by grouping. Okay, so if I did factoring by grouping, I'm going to use -6 as my guide, and I want to break these two terms up. So plus 3x minus 2x should do the job, and then we have 6x squared minus 1. So yes, so once again I'm using factoring by grouping. So looking at the first two terms, we could factor out 3x, and then 2x plus 1 remains. Factoring out -1 leaves 2x plus 1. So we have 2x plus 1 in common. We could factor that out. And 3x minus 1. So yeah, so our original function can be factored. So our original function fx equal to 6x to the 4th plus 7x cubed minus 12x squared minus 3x plus 2. That in a linear factored form would be, originally we have x minus 1, so we have x minus 1, x plus 2, and then these last two that we just factored, 2x plus 1 and 3x minus 1. Okay, and if we set all these factors equal to 0, we see that the zeros of fx, the zeros of this function fx are -1, -2, -1/2, and 1/3. Okay, so those are the possible zeros. Not possible zeros. Those, in fact, are the real zeros. And if we looked at the possible zeros, we should see all these numbers here. All these zeros would be on the possible zeros, right? Okay, so so if we look at 1/2 and 1/3, you see 1/2 and 1/3. We have 1 here and we have 2 here. Okay, so yeah, so it works out fine. Okay, that's it for this video. Thank you for watching.